Alright guys, let's take a look at page 305. Alright, yesterday we ended our class looking at this chart that we completed on page 304. Today I want us to be able to look at this chart a little bit more in depth and try to find a pattern between the first two columns that told us something about the graph and the last two columns that told us something about the equation. So we're eventually going to fill in those patterns at the top of page 305 to give you a little hint. There should be kind of 4 things that we should notice. But I want you to just take a moment, look at the table that we filled out, and see if you can find any patterns or connections between the first two columns and the last two columns. Do we see anything? Maybe? Go ahead, Maggie.
If the base is between 0 and 1, there's no y-axis flips and it's the pattern.
Okay, so base is bigger than 1, bigger than 1, bigger than 1, but you said no y-axis flip. So bigger than 1, bigger than 1? Or did you say between 0 and 1?
It's between 0 and 1, there's no y.
Sorry, I was looking at the wrong ones. So between 0 and 1, 0 and 1, 0 and 1, no y-axis flip. Okay, we have decay, 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 decay. I like it. If we do have a y-axis flip, notice how it changes to growth. So it seems like a y-axis flip can change the classification of growth or decay. Maybe we'll write that down here. Y-axis flip changes growth / decay. Oh, we can't see it, sorry. Can we find another pattern? We got anything? I know it's a lot to look at. We're trying to figure out how the right two columns and the left two columns might have a connection. Maybe we'll chop this in half so it's less for us to look at. Let's just look at numbers 1 through 7. Or sorry, 1 through 6. Because those are the ones that we said that didn't have any reflection or flip. Can you find a connection between the first two columns and the last two columns? You see it, Travis?
If it's increasing, it's growth unless there's no effect. So that's like including all other columns.
Okay, so if we just look at the first 6, if it's increasing, then it's growth. Can we make another connection maybe to this last column? I know these are all none, so that's not going to change. Yeah. B is greater than 1. Okay, increased growth bigger than 1. Increased growth bigger than 1. Increased growth bigger than 1. We see it all the way through? All right, so then if we look at the other ones, decreased decay between 0 and 1, decreased decay between 0 and 1, decreased decay between 0 and 1. I say that's a pattern, right? That's what we're going to go with. So on the next page, we're going to write down maybe those 2. If the base is bigger than 1 with no flips, meaning no reflections, and the other one was if the base was between 0 and 1 with no flips. All right, so if we look at 1 through 6 again, we said if the base was bigger than 1 with no flips, we had an increasing growth graph. Okay, on the other hand, if we had between 0 and 1 with no flips, we had decreasing decay. All right, let's see if we can find some more. This time we'll focus on the bottom half, so 7 through 12. Can we look for some more patterns? Now that if we start to throw in a flip, how that might change things? Let's maybe think about our possibilities. Okay, if we go back to some of these patterns, the first 2 we did looked at the base and we assumed we didn't have any flips. Okay, and then we concluded what the graph would look like. If we think of other possibilities, our base could be bigger than 1 with an x-axis flip. Okay, so maybe that's going to change the graph somehow. But we also have the possibility, if the base is bigger than 1, with a y-axis flip. Okay, maybe that changes the graph a little bit differently. All right, we can kind of write the same pattern, but if the base is between 0 and 1. All right, so let's see if we can start to find a connection with what the graph is going to look like. So for number 3, we're going to look at base values that are bigger than 1, but we want to separate a difference between an x-axis flip and a y-axis flip. All right, so we'll go back to our chart. So if I look at base is bigger than 1, I have 3 of them to consider. Can we conclude something about the shape of the graph, either based off of a y-axis or an x-axis flip? Can we make a conclusion from the table? let's see, if I look at my little check marks, both of these were x-axis flip examples. And if we look at the graphical connection, it seems like they were both decreasing growth. So over here, if our base is bigger than 1 with an x-axis flip, we have decreasing growth. On the other example, we had a base bigger than 1. This time it had a y-axis flip, and we have decrease decay. Does this kind of fit the pattern that Maggie noticed previously? She kind of noticed that a y-axis flip changes the growth and decay. Notice how previously, if we didn't have any flips, we said that a base bigger than 1 was growth. And now notice if we do apply a y-axis flip, it's now decay. All right, we're not really considering the increasing or decreasing part. We're just strictly looking at the growth or decay. So it seems to make sense based off what Maggie saw earlier. Let's maybe do the same thing for the base between 0 and 1. So that's these three. It seems like an x-axis flip. Oh, wrong one. An x-axis flip is going to lead us to increasing decay, whereas a y-axis flip is going to lead us to increasing growth. All right, so the x-axis was increasing decay, and then y-axis was decreasing growth. Yeah. Mm-hmm. All right, let's maybe make note of another one. Okay, so in addition to this y-axis flip that changes the growth and decay value, can we perhaps notice something about the increasing and decreasing nature? If a base was bigger than 1 with no flips, it was increase. But we said over here, if the base was bigger than 1 with either flip, we have a decrease. So it seems like no matter if we have an x-axis flip or a y-axis flip, we're changing the increasing or decreasing nature. Okay, so maybe in addition to this one, we'll say either x-axis or y-axis flip changes the increasing / decreasing. I know it's a lot to take in because we had a lot of information, a lot of data. We're just trying to find patterns or relationships between everything. Okay. So what we're going to do is kind of use these patterns that we saw on the table today to officially make a possible graph based off of an equation. Because if we can start to look for flips and base values, we should start to be able to determine what type of graph we should have. Increasing growth, decreasing decay, whatever that might be. At the bottom of this page 305, I want us to take a look though at what the basic shape of an exponential function looks like. When I say basic, I mean no flips. Okay, basically a parent function, something that you're starting with. So in this case, we kind of have two different options. We can have a base that's bigger than 1, or a base that's between 0 and 1. All right, so to help us with these basic shapes, we're going to look at numbers 1 and 2 from the top of the page. Notice how we said a base bigger than 1 with no flips should be increasing growth. So your pencil should be going up and you should be going away from a horizontal asymptote. Something like that. Okay, if the base was between 0 and 1 with no flips, we should have decreasing decay. So your pencil should be going down, and you should be getting closer to the horizontal asymptote. So these are going to be our basic pictures. We're either going to start with the first one, start with the second one, and somehow we're going to manipulate it with the flips that we identify. Can we think about perhaps, though, maybe a scenario that we didn't really account for with these 4 patterns? We looked at no flips, we looked at x-axis flip, we looked at y-axis flip. Is there a 4th one? Yeah.
Flip both.
What if we do it both ways? Okay, what if we flip the graph upside down and then left and right? Okay, what's that graph going to look like? So we'll say, what about both flips? Okay, that's something that our table from yesterday did not consider. So we're going to take a look at that case in this new table. So if you look at the first one, looking at the equation, we can notice that we have 2 negatives. One of them is out front, and the other one is in the power spot. Just to kind of review, can we maybe list which one or which negative represents the x-axis flip and which one represents the y-axis flip? You kind of have a 50-50 shot, yeah?
Negative in the power is the x-axis one.
Negative in the power is the which one?
X-axis.
Close. It was a y-axis. 50-50 shot. This one out front is an x-axis. Okay, so the fact that we have 2 means we have both, but depending on where the negative is, you can classify which one is which. So looking at our first one, is the base value bigger than 1 or between 0 and 1? Somehow we got to figure out which basic graph we're starting with. Can we identify the base? What number is being raised to a power? Do we see the 2/3? Okay, and 2/3 is between 0 and 1. Okay, number of reflections, we said there should be 2 because we have a negative out front and in the power spot, so we're actually going to flip this both ways. So let's think about what this final graph should look like. The fact that the base is between 0 and 1 means that we're starting with this decreasing decay. Okay, this is our parent function, the one we're starting with. But we have to flip this graph both ways. We have to flip this graph upside down, and then we flipped it left and right. Okay, you could do it the other way. It doesn't matter. You just have to do both. So can we visualize what the final graph would look like in the end? If you were to flip this graph upside down, it would probably look like that. But now we have to flip this graph left and right. So that means this side that goes down on the left-hand side is now going to go down on the right-hand side. And this right side that approaches the asymptote should now be on the left. So if I kind of connect those 2 ideas, I can create my final graph. So the base value is cluing us into what we're starting with in terms of our basic picture, but the flips are telling us how to change it in the end. So how would we classify this final graph? Growth, decay, increasing, decreasing. Can we be specific? Decreasing, because my pencil goes down as I draw it. Growth or decay? Growth. Okay, on the right-hand side, we go away from the asymptote. All right, so decreasing growth. So without a calculator, okay, we can just look at an equation, pick apart different things that are written in the equation, and those are cluing us into what a possible graph is going to look like. Let's see if we can do the next one. Notice how we have a negative out front as well as in the power. So we have 2 flips. Can we identify the base? What number is being raised to a power? Go, Blair? 2. All right, so our base is bigger than 1. So let's think about what this possible graph is going to look like. The base is bigger than 1, so we're going to start with this increasing growth graph, but now we have to take this graph and flip it both ways. So let's see what that's going to look like. If I take this basic graph and flip it upside down, it's now going to look like that. And if I take this graph and flip it left and right, it's now going to look like that. Can we classify it? It's definitely decay. The right-hand side approaches an asymptote. As you trace it, your pencil goes up, so increasing decay. Do you guys think you can try the last one? Try to get a rough picture.
Wow, those are beautiful graphs. I always put on just 40. It's 1/2. There's 1/2. How does it work? Well, because she likes to make us down.
Did we get decreasing growth in the end? Sounds good. Okay, so if we take a look at this, clearly our picture for 3 was very similar to our picture for 1. And hopefully that makes sense because notice how both of them had a base between 0 and 1, and both of them had the 2 flips. So they should look relatively similar. But we could probably make these be a little bit more specific in their shape, okay, or in their characteristics, because based off the way we drew them now, they look exactly the same, but if we were to put them in a coordinate system, they'd be a little bit different. Is there any other number in these equations that we could possibly use to help us determine another characteristic about this graph that we drew? Yeah.
The constant.
What does the constant represent?
The horizontal asymptote.
The horizontal asymptote. So even though 1 and 3 seem to have the same basic shape, which is a good starting point, this graph has a horizontal asymptote at 3, whereas this graph has a horizontal asymptote at -2. So they're at 2 completely different spots on a graph. They have the same basic shape, okay, that decreasing growth characteristic, but they're in different places. Okay, so these are just rough sketches. We can start to get a better feel for the graph when we start to include that horizontal asymptote location. All right, let's take a look at one more thing. When we said previously, either an x-axis or a y-axis flip changes the increasing and decreasing nature, what happens if we have both? If we have a base between 0 and 1, it starts as decreasing decay. If we have both flips, it changes to decreasing growth. So does either the x-axis or y-axis flip change the increasing and decreasing nature? It certainly doesn't if you have both at the same time. So we're going to throw in but not both. Okay? So if you only have one, you're changing the increasing or decreasing nature from the beginning basic graph. If you have both, though, it happens to stay the same. Okay, we can start to make these little connections or patterns between the equation and the graph. Okay, everything's related. Everything's connected. All right, let's go ahead and we're going to fill in two more things here. I was planning on doing it on the next page, but instead of rewriting everything, we'll just do it here. So notice how for 1 and 2, I kind of had this extra line in here that was left empty. Shh, gentlemen. We're going to fill that in a little bit more. So what if we had a base bigger than 1 with both flips? Okay, before we only really considered if we had no flips. And then for number 2, what if our base was between 0 and 1 with both flips as well? Okay, maybe we can use our table below to kind of help us fill in these characteristics, but we've seen patterns before that we could probably use to help us without actually needing an example. So if we have both flips, do we change the increasing or decreasing nature of the graph? We saw no. Okay, if it's only 1, it does, but if we have both, it's no. So this is still going to remain increasing. Now, if we have both flips, that means we have an x-axis and a y-axis. And Maggie mentioned previously, one of the first things was if we have a y-axis flip, it changes the growth and decay. So if we're starting with a basic growth graph and we have both flips, which means there's a y-axis flip in there, this would have to change to decay. Does that fit what we said in the table? If we have a base bigger than 1 with 2 flips, we should have increasing decay. Seems to make sense. Okay, let's try if we have a base between 0 and 1. If we have both flips, the increasing or decreasing nature does not change. So this is still going to be decreasing. But if we do have both flips, that means there's a y-axis flip in there, so the decay / growth nature will change. So if we started with decay in the basic graph, it's going to change to growth. Does that fit what we said in the table? Base between 0 and 1, 2 flips, decreasing growth. Okay, so with these 4 little lists here, we've kind of went over every single possibility of the type of base we can have, the type of flip we can have, and therefore the type of graph that it's going to produce. I know it's a lot to take in, like I said previously, because we have all these different characteristics. What I think is going to be a little bit easier for us to think about or analyze is this flipping aspect that we did to help us draw these graphs. If you're a memorization person, this is for you, numbers 1 through 4. If you're a conceptual person, you have to think about it. We're going to go through the flipping process to help us get the final result. Okay, either way, memorizing or conceptual, you'll get there in the end. Okay, you just have to pick one that you're more comfortable with. All right, so this page will just say same, okay, as before. It was just another space for us to rewrite those characteristics if you needed more space. All right, let's try these 3 on the bottom. Now, just by looking at an equation, we're going to try to predict what the graph looks like. Is it increasing, decreasing, growth, or decay? Okay, what's the combination? So in order for us to identify what the graph looks like, we have to start to pick apart different pieces in the equation. So I want us to think about what is our base value, do we have any flips, and where is the horizontal asymptote? Okay, these different characteristics are going to help us get an idea or give us a clue about what the graph's going to look like. So based on number 1, can we label what number is representing the base? 2. Okay, so that base is bigger than 1. Can we label any flips? We have a negative out front, so that's an x-axis flip. Can we think back from yesterday? We mentioned how if we have a negative leading coefficient, how that relates to the graph. This was like our A value. I think we used that letter yesterday. Good, Logan?
If it's negative, it's below the horizontal.
Okay, so ultimately, if you have an x-axis flip, which means you have a negative leading coefficient, your graph should be below the horizontal asymptote. Speaking of the horizontal asymptote, can we figure out where that is based off the equation? Y equals 3. Okay, so let's start to think about what this graph is going to look like. I'm going to throw in a horizontal asymptote. I'm going to label it as 3. Since I have an x-axis flip, I know I should be below that asymptote. The question is, do I have a decreasing growth, because that's below the asymptote, or do I have an increasing decay, because that's also below? These are your only two options based off of what we said here so far. So we have to analyze it a little bit further to figure out which one of the two it is. All right, so let's think about this. If our base is bigger than 1, what does the basic beginning graph look like? Can we classify it? If our base is bigger than 1. All right, we said that was increasing growth. I'll label this basic. So now we're going to take a look at the flips to help us see if we have to change either of these characteristics. So we have one flip. What does that change? Increasing, decreasing, growth, or decay? Can we go back to maybe some of these patterns we found? Let's see, we said either x-axis or y-axis flip changes the increasing or decreasing, but not if you have both. So the fact that you have one means that we're changing the beginning increasing nature, and it's now becoming decreasing. All right, let's see if we have to change this growth nature. Okay, based off of what Maggie mentioned earlier, if we identify a y-axis flip, it changes the growth or decay. Did we list that? No. So this is going to stay a growth. So somehow, underneath this asymptote, you have to draw a decreasing growth graph. So your pencil has to be going down, and on the right-hand side, it should be going away from the asymptote. So of the two that I drew previously, it seems like this is the correct shape. All right, now if we check it, based off the 4 things that we listed previously, we said our base is bigger than 1, and we have an x-axis flip. If I flip the page, okay, looking at my different options, I have a base bigger than 1 with an x-axis flip, and notice how we said it should be decreasing growth. That's exactly what we realized here. Okay, so we can either think about these different properties and how they relate to each other, or again, if you're a memorization person, okay, everything's listed there anyway. It's completely up to you, okay, what works best for you. All right, let's try 2. Let's label the base, any flips, and where the horizontal asymptote is. Let's see, our base is 0.25. That's between 0 and 1. Do we have any flips? That's a y-axis this time because we have a negative in the power spot. I know it might be a little hard to see. Okay. Horizontal asymptote at -2. Okay, so let's go ahead and draw a rough sketch. Horizontal asymptote, -2. Since my leading coefficient is not negative, I should be above the horizontal asymptote. So maybe I'll draw that down here a little bit more. Okay, so we need to have a graph somewhere up here. And if you think about your options, you either have increasing growth or decreasing decay. We have to figure out which of the two it is. So when we think about the basic parent graph, okay, the one that we start with, our base is between 0 and 1. That is a decreasing decay. So for this new one, okay, that we're going to flip left and right, we need to see if we have to change either of these descriptions. So since we did identify one flip, the decreasing or increasing nature changes. So if this started as decreasing, it should now be increasing. We also identified that we have a y-axis flip. So that's actually going to change the decay or growth nature. So if it starts as decay, it's going to change to growth. So between these two options, we need an increasing decay. That would be increasing growth. That would be the one that goes up to the right. Okay, if you wanted to check it, okay, using the 4 properties we had on the front, our base is between 0 and 1, and we have a y-axis flip. So over here, base is between 0 and 1, y-axis flip, increasing growth, just like we said. Are we doing okay? I know it's a lot to take in, but we're going to have more practice. Okay? We'll go ahead and check out the last one tomorrow. That's going to be a good review.